Okay, today we're going to be talking about the Pythagorean theorem. So the Pythagorean theorem is something that we use with right triangles. Now, a right triangle is when we have a right angle or a 90-degree angle in our triangle. Now, there's something true that every single right triangle, if we take the two legs of the triangle, these are the smaller sides, and let's call them A and B, and we square them and add them together. So A squared plus B squared, that is going to equal the square of this longer side, otherwise known as the hypotenuse. We'll call that C. So C squared. So this is the Pythagorean theorem. A squared plus B squared is equal to C squared. So the two smaller sides squared. It doesn't really matter which one you call A, which one you call B. It could be interchangeable because when we add them together, they're going to be the same number. So you just take those two smaller sides, square them, add them together, and that's going to equal this longest side squared. Okay, so we are going to do some examples of solving for missing sides of a right triangle using our Pythagorean theorem. So let's look at this first problem right here. So the missing side is going to be the longest side, right? We always know which side the longest side is from our right triangle because it's the one opposite that 90-degree angle. So that 90-degree angle basically points to the longest side there. Okay, so 90 degrees, the opposite side is your hypotenuse, or the C, in the Pythagorean theorem. So if I know that C, I know that if I square these two longer sides and add them together, that are equal to this side squared, it's going to be equal to each other. So let's do that. So 10.3 squared plus 8.6 squared is going to equal this x, whatever that is, squared. Okay, so 10.3 squared is going to be 106.09. So 106.09, and then 8.6 squared is 73.96, and that's still equal to x squared. So now let's add them together. 73.96 plus 106.09 is going to be 180.05. That's equal to x squared. Now, you would think we were done, but what are we trying to solve for? We're trying to solve for x, right? This is x squared. So somehow I need to get rid of this square on this side and get it back down to x. So what is the opposite of squaring something? Opposite of squaring something is square rooting. So I have to find the square root of x, and if I square root that side, I have to square root this side. Okay, square root of any number would be, so x squared is x times x, right? When you square root, you find that root, so that number is multiplied by itself. So the square root of x is just going to be x. Okay, but then to do the square root of 180.05, I need a calculator. So square root of 180.05 is going to be 13.4182, blah, blah, blah. Let's round that to our hundredths, the second decimal spot. So it would be 13.4. And that would be my answer. That is the answer to the longest side squared. Okay. Now that I found the longest side there, let's look over here at the second problem. This problem, again, the 90-degree angle always points to the longest side. So this is my longest side, which means the one that it wants me to solve for is going to be one of my legs. So if I come up here and look at it, it's going to want me to solve for either A or B. Okay, it's a little bit different, but really it's pretty much the same type of problem. So let me show you. So x is going to be one of my sides, so I'm going to plug it in for A. Doesn't really matter which one. But we'll say it's x squared there plus 9.5 squared is equal to 14.3 squared. Okay, so then I square stuff. So I've got 9.5 squared is going to be 90.25. And then 14.3 squared is 204.49. Now I want to solve for x. So again, before I can solve for any variable, it needs to be by itself, right? So I need to move this 90.25 to the other side. Right now it's adding. To move it, I would subtract out the door. So 90.25 minus 90.5, 90.25 minus 0, so those are gone. And then 204.49 minus 90.25 is going to be 114.24. That's equal to x squared. So again, my goal is to solve for x. Is x by itself yet? Nope, it's squared. How do I undo a square? I have to square root. If I square root one side, I have to square root both sides. Square root x. Square root of x is x squared is x. And then the square root of 114.24 is going to be 12.00999 blah blah blah. So I round up to the nearest hundredth, and it's going to be 12.01 is my answer. Okay, not too hard, right? One other thing you might see is something like this section over here, where it doesn't give me the triangle, but it gives me two side lengths and it wants me to find the side that is negative. So the sides are always described just like with the Pythagorean theorem, A, B, and C. Okay, so if I look at this problem right here, I have A and C, so that must mean it wants me to solve for B. Okay, so I just plug it in here. A is 6.7, so 6.7 squared plus whatever B squared is equal to C, which is 14.9 squared. I square them. 6.7 squared, 44.89. Write it down, 44.89 plus b squared is going to equal 14.9 squared is 222.01 minus the 44.89. 22.01 minus 44.89 is going to give me b squared is equal to 177.12. The last thing I do is square root. Square root of 177.12 is going to be 13.31. Rounded to the nearest hundredth. Okay, that's really all you do in that section. You just look for the letter that isn't there and you solve for it. Okay, and that is how we use the Pythagorean theorem to solve for the missing side of a triangle.